Okay guys, here we go on lesson 2. So in the previous lesson, you learned about the mole and what it entails, namely that it is 6.02 times 10 to the power of 23 particles in one single mole. Now we are going to be doing quite a few calculations for the rest of the semester using the formula N equals uppercase N over uppercase N subscript A. So remember, we've got number of moles, number of particles, and there's Avogadro's number. Now, I really don't like the triangles, but I'm including it right now just because we need to actually see how they interact. So right here, if I were to do, I don't know, that, this would give me number of particles, Avogadro's number, and number of moles, right? This connects with that formula right there. However, we are today going to see how it interacts with other variables. Look at this other triangle that's forming. How excited are you right now? So, just going to isolate this first one. So you see here is one formula that we'll be using that involves number of moles. We are going to add 2 more to this today, and there's even more at the end of the semester because it's the best. So number of moles, we are also going to relate it to mass, all right? N equals lowercase m over uppercase M. And I can already hear just how excited you guys are to have 2 of the same letters in a formula, yet again, varying only by upper and lowercase. And I hear you, I do, but I promise it'll just become second nature for you. So this right here is the formula we're focusing on today. And I'm going to go into that in detail in a minute. In the future, though, that's right, the triangle exists down to the bottom here. And we have the variables C and V. So this formula for our final triangle would be N equals uppercase C times uppercase V. And yes, the uppercase matters. Lowercase c represents the speed of light for any of those who took physics already. Lowercase v represents speed or velocity, whether it's a vector. So we need to use uppercase for chemistry because they represent concentration and volume. So if we look, I know on the full note, you filled in a big chart that looks like this. I am not going to copy all this out again, and I think you can understand why. But if you go through, you see that we have a variety of quantities, all with a different symbol and different units, okay? So today we're going to focus on mass, what we call molar mass, and the mole. Up first, what is molar mass? You got it. It is the mass of 1 mole of a substance. Okay, 1 mole. This is where you're going to want to get your periodic tables out if you don't already have them. So find those beautifully laminated sheets that I gave you. If you don't have it home, pull it up on your Chromebook, pull it up on your phone. Thankfully, we have the internet, so you should not have an excuse for not having a periodic table at hand right now. Okay, molar mass, it is measured in grams per mole. Okay, that is grams per mole. And we are going to calculate it using masses on the periodic table. So using those atomic masses on the periodic table. So for example, molar mass of an element is equal to its atomic mass. And take a look at how I'm going to note it now, what sort of notation I'll use. So uppercase M, that is the symbol for molar mass. You know that now. I've said it multiple times already in the 4.5 minutes I've been talking. Now, for example, I don't know, iron. Okay, so I would have uppercase M and then as a subscript Fe. And if I turn to my periodic table here, there's a bit of a glare, but I find iron. I zoom in. And I see the atomic mass right there, 55.85. So when I return to my note here, I'm just going to use that with the appropriate units. So the molar mass of iron is 55 0.85 grams per mole. Right now, I'd like you to find the molar mass of copper. Press pause, refer to your periodic table, write it out with proper notation. Hopefully you did that. And you're going to see now that the molar mass of copper is 63.55 grams per mole. Easy peasy for elements, right? We're going to mix it up a little bit. Well, not mix it up. We're going to go on to actual compounds. So for molar mass of compounds, we need to count the number of units of each element. Molar mass of compounds. I apologize, guys. I'm trying not to have these awkward pauses in the videos, but I also can't have it all pre-written or it defeats the purpose. So molar mass of compounds, we're going to count the number of each particle. To do so, we need to use the chemical formula. If we look at the molar mass of water, so molar mass of H2O, well, if it's H2O, we see that we have 2 times the molar mass of hydrogen plus the molar mass of oxygen, right? 2 hydrogens, 1 oxygen. So then I'll sub it in. 2 times 1.01 grams per mole plus 16.00 grams per mole, which gives us 18.01 grams per mole as the molar mass of water. My sig digs are intact. This is a counting number, so it doesn't count towards sig digs. Here we have 2 decimals, and we are adding, so we keep the lowest number of decimals. Okay, I'd like you to find the molar mass of, well, this is a tricky one, iron thiocyanate. So FeSCN3, right there. Press pause, see what you can figure out. If you need a hint to start, we see that we're going to find the molar mass of 1 atom of iron. Then we have 3 sulfur, 3 carbon, and 3 nitrogen. So plus 3 times the molar mass of sulfur, plus 3 times the molar mass of carbon, plus 3 times the molar mass of nitrogen. So that gives me 55.85 grams per mole, plus, this piece here is going to block me from it, so I'll have a little staggered line, plus 3 times 32.07 grams per mole, plus 3 times 12.01 grams per mole, plus 3 times 14.01 grams per mole. Okay, so when I simplify that, I get my molar mass of 230.12 grams per mole as my molar mass of iron thiocyanate. So that is calculating molar mass. What we can do though is we can recognize with this equation of N equals lowercase m over uppercase m. This is equal to number of moles equals the mass given of a substance divided by the molar mass. And think of it this way. If I told you that we need to know the number of egg cartons, okay, that would be equal to the number of eggs in total divided by 12 eggs per carton. Right? We're just looking at how to quantify this and group it all together in a more usable way. It's much nicer to talk about 1.2 moles than it is to talk about 6 point something times 10 to the 23. I didn't do that math in my head fast enough for you guys. All right, so a question I might ask with this would be, how many moles are in 41.7 grams of copper 2 chloride? So what are we being asked here? Let's figure it out. right off the bat, how many moles? That's what we're being asked for. So we're being asked to find lowercase n. We have been given the mass of the sample, so that's lowercase m. Right? N is unknown. Our mass is 41.7 grams. And our m, okay, uppercase m, our molar mass, we need to calculate. So that's for CuCl2, and I'll calculate it right here. That's going to be the mass of copper plus 2 times the molar mass of a chlorine atom. That's going to be 63.55 grams per mole plus 2 times 35.45 grams per mole, which gives 134.45 grams per mole. Now, have I met sig digs? I have, because this is addition, so I just have to watch my number of decimal places. Now, I'm not done my question. Okay, I'm looking for how many moles. So I need to use N equals lowercase m over uppercase m, mass divided by molar mass. So that means I'm going to take 41.7 grams and divide it by 134.45 grams per mole. And that's going to give me 0.31015 moles. Let's check sig digs. This is division, so I need to use the lowest number of sig digs available. I've got 1, 2, 3, 1, 2, 3, 4, 5. Well, 3 is lower than 5, so I'm going to round to 3 sig digs. Equals 0.310 moles. So there are 0.310 moles of copper 2 chloride in a 41.7 gram sample. And I know that every time I say I use it, you guys sort of laugh because I'm the one teaching a chemistry course, but this is a really, really basic and important concept in chemistry that is used all the time. So we are going to need you to get very, very good at this. Let's do one more problem together. For example, you are told to use 2.2 moles of magnesium for the following reaction. So I want magnesium to react with hydrochloric acid to form magnesium chloride and hydrogen gas. I want to know what mass, not what amount. Okay, I don't have a scale that reads moles because it varies for every single compound. I want to know what mass of magnesium I should be using. So right here I have lowercase n. I don't have anything else in the question, but the beauty of molar mass is where do I find it? That's right, on the periodic table of elements. So N is 2.2 moles. Now, molar mass, we're looking for magnesium. So molar mass of magnesium is read directly from the periodic table, and that is 24.30 grams per mole. So if N equals mass over molar mass, well, when I rearrange it, I have mass equals number of moles times molar mass. So that gives me 2.2 moles times 24.30 grams per mole, which gives me 53.46 grams. Now look right here, that's 2 sig digs, so I need to round it to 53 grams. Therefore, weigh out 53 grams. So I'm going to post some textbook questions for you guys to work through for this. I'm also going to post, it's going to be called a quiz, but I want you guys to know this is more of a formative assessment and not actually counting towards your grades. I will do a quiz for everything by the end of the week that is going to count towards your grade. So again, if you have any questions, please post in our discussion forum. Please answer any questions for a friend or classmate that has one in there. And when in doubt, come on and drop into the Zoom room, and I will see you guys there with any questions in person. Have a great day. Bye-bye.